Hello, once again, thanks for joining us on Space Nuts. I'm your host, Andrew Dunkley. Please forgive my voice. I have been dealing with that COVID thingy that's been going around. Hadn't heard about it before that, but apparently it's some nasty illness that I'm afflicted with. But getting by. Coming up on this week's program, episode 311, we'll be looking at an old, well, not old, but a recently discovered asteroid that's back in the news. And, of course, it's World Asteroid Day this week. We'll tell you about that. You might have seen the story in the news about the rocket body impact on the moon. We'll talk about that because they got the picture they were after. Remember we talked about that? And the NASA launch in the Northern Territory and a new instrument that could be a game changer in the search for life beyond Earth, plus audience questions. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as always, is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. You don't sound as bad as I thought you would, I have to say.
You should have heard me yesterday.
Yes, maybe yesterday was the day.
Yes.
To keep up the good work, it'll come good before long. That serene voice that you normally have is on its way back.
It's a very, very ordinary voice at the moment, but
yeah,
we'll battle on. I've been through it before with other lurgies, but losing your voice in my industry is never much fun.
No, that's right.
Especially when the program director complains that he has to do breakfast while I'm away because he doesn't like it.
No, well, who would?
Oh, well, yeah, it's my way of getting even.
Yeah.
But, battling on. Don't know where or when or how I caught it, but I caught it. So I knew it would happen sooner or later. But it was funny because I did a rapid antigen test and I left it on the kitchen bench and I almost forgot about it. And Judy came into the lounge room and looked at me and she said, "You're positive?" I went, and I looked at her and went, she said, "No, I'm not kidding." And I should have known because she never jokes. And I went out and looked and, yep, there were the two thin pink lines.
The two lines, the two red lines.
Either that or I was pregnant. So...
Right.
Yeah. But, it's just been hunkering down ever since because we're still under those requirements to isolate. Some countries have gone, don't worry about it. But we're still doing the isolation thing. So hopefully I haven't spread the love. Now, Fred, let's get stuck into this. Firstly, let's talk about the moon impact. Now, some time ago, it was forecast that a rocket body of some description would impact on the moon, and they were wanting amateur astronomers to get as many pictures of the moon as possible to maybe find this thing, and voila, they've got a photo.
Yeah, slightly more complicated than that because when it was picked up, which was during pretty well the last week in February, if I remember rightly, it was detected in orbit around the sun. I think actually it might be around the Earth, a very distant orbit. But anyway, the prediction was made that it was going to hit the moon on March the 4th, and it was going to hit the backside of the moon, and indeed it did. So what was happening was amateur astronomers were encouraged to try and image it, to get positions for it during the period in which it was approaching its final demise, because the more positions you can get of something like that, the better you can determine its orbit. And so that was, that was all done. There was a bit of controversy that week because it was first thought to be the remnants of a rocket body that SpaceX had launched. I think it was a geostationary satellite some years earlier, probably, I think 5 years earlier, and maybe even more than that. But that turned out not to be the case. That was eliminated. And the suspicion was that it was a Chinese rocket booster. But China said, no, we haven't lost any of our rocket boosters. It ain't us. And now what's happened is that, I think it's actually quite a little while ago, but the Lunar Reconnaissance Orbiter spacecraft, which reconnaissances the moon, has actually sent back an image of a newly discovered, not one crater, but two craters, a pair of craters, which are being interpreted as the crash site of this spacecraft. And that's the big surprise, that it's two craters and not one. They are roughly 17 meters in diameter each. One's a bit more, one's a bit less. And they kind of just overlap. So they're separated by around about 17 meters, their centers. And that is really interesting and very unusual and unexpected, because everything else that's hit the moon, and there's actually quite a large number of objects that have hit the moon, many of which have left craters, which have been detected by orbiting spacecraft. In fact, Arizona State University reckons at least 47 NASA rocket bodies have hit the moon. So there's a lot there, but they're all single craters, and this is a double one, which is really causing the pundits to scratch their heads. The best guess is that what you're talking about here is an object that had a mass at each end of it. So normally you get a single crater. All the mass in a spent rocket body is actually in the end where the engines are.
Yeah.
Fuel tanks are empty by then. So the heavy bit's the engine bit, and that gives rise to the single crater. But it's perhaps, it's giving speculation that perhaps this object had a heavy mass at each end, giving us this double crater separated, as I said, by about 17 meters. So that's the story so far. What's going to happen next? Well, the world space community is trying to find whether there are any previous observations of this object that might have been recorded by amateur astronomers who were taking astrophotos of the sky and unwittingly recorded this object before it was first sort of spotted, back earlier this year. And the idea then is that if you can find earlier observations, you can get a much more accurate track back of the orbit, which might actually allow you to identify which spacecraft it is. I think it's fair to say that suspicion still falls on the China National Space Administration, partly because they don't usually say too much about the rocket launches and the exact details. So that might well be the source of it, but everybody's quite keen to find out what it was. Something with a weight at each end of it. That's a very unusual piece of space.
Yeah, that is fascinating. As you alluded to, no one's owning up. Everyone's staying very quiet about this.
Nothing to do with us. Nothing to see
Nothing
here.
to see here. Yes. But, look, we may never find out. But
we might not. That's right.
I kind of, amusing's not the word, but the way people sort of deflect and ignore things like this because they don't want to be blamed. I think on the scale of this event, it's not the end of the world. So why are you being so tight-lipped? Just say, yeah, sorry, it was us. We'll get up there and clean it one day. Well, we promise.
Maybe it had something on it that they didn't want anybody to know about.
Well, that's potential.
Whoever it was.
That's a potential fact as well. Yes, indeed.
The double crater has basically spilt the beans on this.
Yes, could well be revealing something that they don't want us to know about. Yeah, good point. All right. Well, if there's more to tell on this story, we will certainly tell you eventually. Yep. I suspect it's going to be hard to find out anything more.
It might be a while, that's right.
Now, the other interesting news about a rocket body is the NASA launch that happened on our own turf here in Australia for the first time in 200 millennia, or maybe a bit less, in the Northern Territory. They got that one off the ground last week. Yeah. Yes,
that's right. Indeed. Yeah, big event, and a bit of a triumph for our new space agency. Well, new as of 2018, because they're the regulatory body for this sort of thing. They've talked with NASA a lot. NASA is actually planning 3 launches from this newly created Arnhem Space Centre up there in the Northern Territory. It's on the remote eastern edge of the Northern Territory. And you always want to put things like this on the east, because for orbital spacecraft, you're always going to launch to the east to catch a bit of tailwind from the Earth's rotation. And so having an area of sea or ocean beyond is a good idea, because then any spent rocket bodies that come back just go splash in the sea and don't do damage. So we saw, as you said, we saw the launch. It's a suborbital launch. So the three that NASA have booked with the Arnhem Space Centre, and this was the first one, they're all suborbital launches carrying astrophysics equipment, actually. They're definitely going to space because they're well above the Kármán line at 100 kilometres. These things go roughly 300 kilometres into space. And this particular experiment was actually about nearest neighbours in interstellar space, Alpha and Beta, Alpha Centauri, the Alpha Centauri system. And so really exciting stuff to see the first space launch from Australian territory for many, many decades. You might remember that there was a lot of activity at Woomera in South Australia back in the 50s and 60s. I remember reading about all that from my home in the north of England when it was all happening. But then things quietened down a lot, and now we're back in the business of having space launches. And just a final note on this, Andrew, the Arnhem Space Centre, when it comes to launching orbital rockets, is really in pole position because they're only, I think it's 11 degrees south of the equator.
Yes.
And the nearer you can get to the equator, the bigger the kick you get from the Earth's rotation. So
it certainly suggests Woomera was probably not the best place to launch rockets.
Well, that's right. I think Woomera was more an experimental test station for rockets themselves rather than for putting satellites up. Although one was the RESAT, it's WRES. What was that? The Weapons Research Establishment, I think. RESAT was satellite launched by then.
Yeah. No, it's good. It's good that we're back in business. It's taken a while, but yes, bigger and better things to come, I would imagine, yeah.
I think so, yes, that's right. Okay. Very exciting.
Yes, indeed. Excuse me. There we go. And to our next story, we're going to sort of dovetail three into one here. And this is about an asteroid that I think was discovered a few years ago, but it's back in the news because they've released a scientific paper on some of the information gleaned from this. And from what I've read, this was something that's sort of happened very, very quickly because of the window of opportunity that was so narrow.
Yeah, that's right. Just a quick heads up, a nice story to have on the day before, as we're recording, World Asteroid Day, which comes up tomorrow. The 30th of June every year is World Asteroid Day and commemorates the Tunguska event back in 1908. So this particular object, which I love the name of this asteroid, it's 2019 OK. Maybe it's not OK because I think it is actually a near-Earth asteroid. So there was, exactly as you've said, it's back in 2019, as you'd guess. 2019 OK was discovered on the 25th of July 2019. There was an alert from, I'm not sure which of those, many telescopes that are actually scanning the skies for rogue asteroids, including Pan-STARRS up there on Haleakala in Hawaii on the island of Maui. Anyway, there was an alert, and it was received by scientists at the Arecibo Observatory in Puerto Rico, the great Arecibo dish, which was still in operation then, sadly no longer, having collapsed due to mechanical failure. But it's still an extraordinary machine. It was 300 meters in diameter in a natural depression in the landscape of Puerto Rico. So what happened was the scientists there got the alert that this asteroid was actually on its way inbound, not on a collision course, but certainly with a potential close approach. And back in those days, Arecibo was perhaps the world leader in getting radar imaging of asteroids, because you basically beam out radio waves and look for the reflections as they come back from the asteroid. Yeah. And so that's what they did. The team at Arecibo, they had half an hour to get as many radar observations as they could fit in. And that's because, being a close approaching asteroid, it was, its apparent speed through the sky was very fast because it was close. And they did. They actually managed that. And the results of those measurements were that this object is somewhere around 60 to 70 meters across. But what was interesting about it, and this is why, this is in the story, this is in the headlines, because exactly as you said, their paper was published a couple of weeks ago in Planetary Science, the Journal of Planetary Science Astronomers. As I said, 60 to 70 meters across, but rotating very quickly. It rotates once every 3 to 5 minutes. It's not quite as well defined as you might like. In half an hour, that's pretty good to find that it actually has this fast rotation. And not that many asteroids, quite a small percentage of asteroids are fast rotators. And it's not really understood fully why they are fast rotators. They also managed to determine that it's probably a C-type asteroid, as a carbonaceous asteroid, which is certainly the commonest type. So that's not out of the ordinary, but the fast rotation is.
Yeah. So they only had a very, very short time to observe this, and on it went.
Went on its way, that's right.
Yeah. Will they be able to observe this again sometime down the track, or is it just a see you later?
It will. I don't know when the next close approach is, but it will definitely be observed again. There is still equipment at Arecibo that is sort of working. There's a 12-meter antenna there that I think has fallen out of use, but because the main antenna collapsed in 2020, they're refurbishing that so that there's ongoing work. And there is still talk of rebuilding the big dish there. Of course, we now have the Chinese FAST telescope, which is 500 meters across, and is also doing great work.
Indeed, yes. All right. Well, we might learn more down the track. But yeah, as Fred mentioned, if you do want to read the article about that discovery, it's on phys.org. The scientific paper is in, and I've lost it.
Planetary Science Journal, I think.
There you are.
Yeah.
One more thing before we finish up in this segment. I've just got a note from someone watching on YouTube. Hi, Visto. He's telling us that a CubeSat was launched by New Zealand last night, which is going to be orbiting the moon.
Yeah, that's one I hadn't picked up on.
Yeah.
I mean, New Zealand's kind of well ahead of us in the launch business. They've got...
Well, they've got volcanoes. That makes it much easier.
Yeah, they do. They do indeed. That's right.
We only have one active volcano on Australian territory, and that's off Western Australia, and it's not even actual Australian soil, but it's I think it's considered an external territory or something.
It is, that's right.
But, and I think they've only ever got one photo of it erupting because no one goes there. It's in the Southern Ocean. It's just, you don't want to go there. Too windy.
No, too windy, that's right.
This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
To our next story, Fred, and really like this one because it brings back into play the search for extraterrestrial life. And this story centres around what could be a real game changer because of a new instrument. What have they developed?
It's really, I think this is quite exciting. So imagine a tool that could, like a camera, almost like something in a smartphone, that you could point at a rock surface and it would light up all the fossils in that surface. That's what this is about. It's actually quite an
It's just the same as us taking selfies, really.
Yeah, you mean... Yes, that's right. We... Both a pair of fossils, but we don't light up quite the same way.
No, especially not me at the moment.
No, that's all right. You'll be all right. It's an instrument that's been around for a while. In fact, I think the original BioFINDER was developed by a company called Misra in 2012. But because of its potential for carrying to Mars, for example, there has been, I think, NASA funding put into it. And they've now got what they're calling the color version. And it's a compact version. The technical name for it is the Compact Color BioFINDER. And I think a lot of the recent work has been done by scientists at the University of Hawaii at Manoa, which is actually in Oahu. That's the Manoa Valley in Oahu, a lovely part of the island. So what it centered on is that you can even fossilized organic remains, and by organic I mean now stuff that used to be alive rather than just carbon containing, that can be even organic remains that have been fossilized for millions of years still have among their chemistry, and that's the things like, the proteins, the lipids, and the stuff that might be present in those fossils. They can be excited to fluoresce. That's the thing. If you shoot a laser at them, they will fluoresce in particular colors. And we know about bioluminescence, for example, the stuff that you see in the ocean, which is an enchanting thing. I only saw my first example of bioluminescence a few years ago, and I couldn't believe what I was seeing. It was in a boat, actually, in Broken Bay here in northern Sydney, and we were travelling at night, a small boat, and I thought there was a light underneath the boat, but it was all these little creatures being excited to luminescence. Extraordinary stuff. Yeah. So living organisms have this facility, particularly if you're exciting them with a laser. And so that's basically how this thing works. It shoots a laser beam at an image field, and what glows is something worth looking at. And they've tested this on material that is new at all. In fact, there's a paper actually, which is the way you do these things. You develop a new instrument and then you publish the paper after the first trial. It's in Nature Scientific Reports, that's the journal, and they've used the BioFINDER to detect what is called bioresidue, in other words, dead biological material, in fish fossils come from a formation known as the Green River Formation. I think that's in the USA, which are somewhere between 34 and 56 million years old. So age is not a barrier to these things being detected. Now, I guess there is a question, because I think as time goes on, the what you might call the veracity of the chemical residues that are left in these fossils, that decays. And so the potential for getting a bioluminescent signal back reduces with age. And of course, on Mars, we're looking for fossilized microbes, perhaps, that might be 3.8 billion years old. So there might not be much left in the bioluminescence signal. But on the other hand, it is certainly worthwhile taking one of these things basically back to Mars when we return there again. Sorry, back to Mars is the wrong terminology, but taking one with us to the planet Mars. So yeah, it's a really, really interesting thing. And I'm just the reason why I'm stumbling here is that I've just realized that I've misquoted there, because I thought MISRA was a company, but it's actually the lead instrument developer actually at the Hawaii Institute of Geophysics and Planetology. Anupan Misra. My apologies, Anupan. I didn't read your paper properly, but I am doing now.
So obviously, being new technology, they'll go through a lot of work to perfect it. But it sounds like it's something that could just become standard equipment on future missions to many places, perhaps.
Yes, that's right. I think it seems like a dream device, doesn't it? If you're looking for signs of past life, and maybe a good place to test it might be on those ancient stromatolites that we know are more than 3 billion years old in Western Australia. It's the possibilities really are almost boundless. Yeah. And as you said, they could test them on ancient fossils like us.
Yeah, absolutely. Yeah,
I'm sure we'd be bioluminescent.
Not sure they'd find much life in me at the moment.
No. You're doing fine, Andrew.
And those stromatolites, I don't think they're there anymore, Fred, because they had to bulldoze them all down for the square kilometre array.
Different part of WA.
I know. Couldn't help it.
Yeah. No, you couldn't help it. No, the square kilometre array. Actually, that's just to talk about that for briefly, because that's it's the site at Murchison, which is in Western Australia. There's a large area there where the antennas of the square kilometre array are being installed, but they do have a very light footprint on the landscape, because these things are just like metal Christmas trees. There are 132,000 of them, but they don't. It isn't a question of digging big holes in the ground. There are some holes for cables that are being dug, but the reason why I'm mentioning that is because, of course, this is a very sensitive area from a cultural point of view.
Yeah.
And our team, certainly in the Department of Industry, is working very closely with the Wiradjuri people of Western Australia to make sure that nothing that is of significance is being disturbed by these antennas, even though they've got such a light footprint.
Would be similar for the Arnhem launch we talked about earlier, because
Yes,
Arnhem Land
right.
is a significant Aboriginal region in the Northern Territory.
Indeed, that's right.
Sacred land.
That's right. And I don't think there's any question but that the Arnhem Space Centre has worked very closely with the basically the indigenous people. I can't remember which nation it is up there. I think it might be the Yirrkala nation, but I might be wrong there. It's, as you know, we regard our First Nations people here in Australia regarded with immense respect here in our country. Actually, the Gamach clan is the local people.
You beat me to it.
Did I?
Yes. Okay. We're going to have a little bit of a break, and then we'll be back with questions on Space Nuts with Andrew Dunkley and Professor Fred Watson.
3, 2, 1.
Space Nuts.
Just a quick follow-up, Fred, on the Arnhem Land Aboriginal people. The Yolngu people is what I found, which probably right.
Yes, it is. That's correct. And we've certainly, some of my astronomical colleagues have had great contact with the Yolngu people up in Arnhem Land in terms of the sky stories that they have and how they interpret the stars. And so, that's a really nice connection with the fact that we now have our first space launch site on that territory.
Yes, indeed. Wonderful. All right. We've got some questions. We'll go firstly we've got a couple from Melbourne. We'll start with Bo, who's talking about, guess what?
Hello, Andrew and Dr. Fred. This is Bo here from Melbourne. I've got a question on dark energy. Surprise, surprise. The question is, can dark energy be thought of as the antimatter particle to graviton under the particle theory of physics because of the expansion effects and therefore anti-gravity effects? And also, if dark energy is accelerating the expansion of space and therefore time, is time slowing down or speeding up? Thank you.
Wow, that's deep. Okay,
That's good stuff.
It's a double whammy. First of all, I suppose, is dark matter the antimatter particle? I'm struggling today.
No, it's all right. So Bo's question's a good one. So the dark energy, of course, is that whatever it is that we don't really know that makes the universe accelerate in its expansion. So it's expanding ever more rapidly. And so that suggests a force field, and a force field suggests a particle, because we know that the two are interchangeable. Now, a graviton is certainly the expected subatomic particle that carries the gravity force field, but we've never found it. We know gravity exists, but there is no theory of physics that actually lets you construct a graviton yet. We hope there will be. We need to find the chinks in relativity, which is our best theory of gravity. Relativity is not compatible with quantum theory, and quantum theory is where you'd be looking for the graviton because it's a subatomic particle. So, yes, notwithstanding that a graviton is something that we expect one day to find, we haven't found it yet. Now, an antimatter version of a graviton would have not a reverse of gravity, but a reverse of its electrical charge, because that's what antiparticles are. They are electrically the opposite, like a positron being the antimatter equivalent of an electron. And a positron has a positive charge, whereas an electron has a negative charge. So in that regard, it wouldn't cause a gravitational repulsion. So I'm not really sure that this is the way that my colleagues in the world of cosmology are actually dealing with dark energy. There are ideas, and I have to say that The one thing that we do think we know about dark energy is that it seems to be proportional to the volume of space that is emitting it. And so as space gets bigger, so dark energy gets bigger, gets higher, and it's a positive feedback. So the acceleration continues. And that's usually referred to in our circles as the cosmological constant, which was Einstein's. It was a term in one of his equations that actually behaves like, we see dark energy behaves like the cosmological constant would predict. I'm sorry, I'm stumbling as well today. I must be coming out in sympathy with your with your COVID-19. Maybe I've remnants of my own infection. So the other part of Bo's question is about a really interesting one.
Time.
So, and my understanding is that in terms of the dark energy, the accelerated expansion of the universe, that is purely space that's affected and not necessarily time. But that is something I'd like to check up on. Space-time is thought to be a single entity, but of course it's got 4 dimensions. And the space dimension, while when you write the equations, it looks a lot like, the time dimension, when you write the equations, it looks a lot like the space dimensions. It's got a negative sign and is multiplied by the speed of light. So that's the trick to it. But it is something separate. So dark energy, whatever it is, in my understanding, only affects space. But I could be wrong there.
Okay.
Whether we would know, however, that time was being affected, because we're within the universe and time ticks away, looks like a constant rate to us because we're all in the same sort of gravity field.
Because we're assuming that time exists, and there was a recent study that suggests that there is no such thing as time, and it's just something we've invented because we needed it.
Yes, that great Einstein quote, time is just a stubbornly persistent illusion. Which he actually, he said that at the funeral of a friend of his. He said it to the widow who was grieving. Don't worry, he's still around. Time is just a stubbornly persistent illusion. Yeah,
well, there are some theories, extreme as they are, that everybody who's ever existed exists still. It's just...
Yes, that we only see this cross-section of time as moment by moment. Yeah, that's the big difference between time and space.
Yes.
Space we can move around in, time we can't.
Exactly. Not yet. Thank you, Bo. We'll stay in Melbourne, and this comes from Peter. This one's a travelling to Mars question.
Hi, this is Peter in Melbourne. I have a couple of questions about humans travelling to Mars. I've read that the ideal time to travel to Mars is approximately every 20 years, and the next time is in 2033. I read that apparently the amount of energy necessary to get to Mars is at its lowest every 20 years or so. And I was wondering why that might be. I was also wondering whether astronauts traveling to Mars would experience the same degree of weightlessness as astronauts in the International Space Station. I understand that weightlessness is a real issue for long times in space. Thanks.
Okay, thank you, Peter. I do believe that the reason the Australian Space Agency was established is so we can send all our convicts to Mars.
Yeah.
Maybe.
Maybe not. Well, you and me would be first on the agenda, wouldn't we?
Probably after that comment, yeah, for sure. For sure. So 20 years.
Yeah. So this is something I wasn't actually aware of, but I can imagine what it might be about. So standard window for going to Mars comes around every 2 years and 2 months. And that's when the two planets are in such a position that you can send a spacecraft from one to the other on what's called a home and transfer orbit, getting from its orbit to Mars's orbit. But it may well be, because Mars's orbit is actually quite eccentric. It's much more elliptical than the Earth's orbit. The Earth's orbit is relatively circular, although it's not perfectly circular. Mars is less so, and it may well be that 20 years comes about when you've got Mars. When you reach Mars, it's at its closest point to the Sun, perihelion. So I wouldn't be surprised that there was an interval like that. But the bottom line is that if you're going to Mars, as we've seen, we've got these launch windows, like the last one, we had 3 spacecraft launched to Mars because it's a popular time to do it. So that's when humans would do it. There are, 2033 is certainly one of the windows on the 2 years and 2 months cycle, because 2035, which will be the next one, is certainly when NASA is thinking maybe that's when they will be launching humans to Mars, but it's still a long way down the track. Many problems to be solved. Regarding weightlessness, yes, all the way to Mars you're weightless, as you are, as much so as you are in the International Space Station, and as it happens, as much as you are when you're on a trampoline and your feet are off the mat. You're as weightless then as you are in space. So that is a problem for long haul space travel. That long period of weightlessness is just one of the many things that has to be dealt with. And people have suggested, maybe tethering 2 spacecraft together and rotating them about their common centre of gravity to give you some sort of artificial gravity. We don't know whether that will materialise. I don't think that's in the present thinking, although it has been suggested. But it's a big issue.
So weightlessness is the same regardless of the way it's achieved, because in this International Space Station, you're constantly falling as a consequence of your orbit.
Yes.
And so the weightlessness caused by that effect is the same as weightlessness travelling from A to B. Huh.
Yeah, because you're doing the same thing. You're actually in an orbit. When you're travelling from A to B, you're in an orbit around the sun, in fact, getting from Earth to Mars. And so you're still constantly falling, even though you're going away from the sun. It's free fall is what we call it.
Understood. All right. There you are, Peter. Short and sharp. Gosh, we're not used to being like that. We do have a bonus question. Well, no, we're just going to throw one more in. This comes from Cincinnati, Ohio, home of James.
Greetings, Mr. Dunkley and Professor Watson. James from Cincinnati, USA here to ask about one of your most beloved topics, black holes. Today, the EHT released the first ever radio image of Sagittarius A star. I'm a bit confused on the perspective. The image looks as if you're viewing a donut, just like the earlier image of M87's black hole. Since we're in a galactic plane, I thought maybe we'd see it edge on. My only guess is gravity bending the light. So does this mean if we're ever able to image any other black holes, no matter their alignment, it'll still be similar in perspective?
Okay. Very thoughtful question. I wouldn't have even considered why it looks the way it looks. But James obviously thought, hang on a minute, what are they doing? How did they do this?
And I think James has got the right answer as well. Because what you're seeing there is... It's not the event horizon. It's not the black bit itself where light cannot escape from that you're actually seeing with this dark patch. What you're seeing with the donut around it is light, or it's actually radio radiation, but we can call it light, that is just missed being sucked in to the black hole. So this is light that's just skimming around the edge of the event horizon and coming our way and leaving a dark shadow in the middle. And so I think that does suggest that no matter what we look at when we look at a black hole, this is what we're likely to see, this shadow of the event horizon. But just tying up James's question, I mean, his comment is absolutely right. My expectation too was that the accretion disk of the black hole would be parallel to essentially to the equator of the galaxy, if I can put it that way. In other words, it will be sitting kind of upright in the middle of the galaxy. And that must have been the case at least at some time, because we know that this black hole has shot material out north and south of the galactic center and lit up gas above and below the galactic center. But when that Sagittarius A star image was released a couple of months ago, is it now, or a month or so, there was certainly an account of the modelling that was done to make all the parameters fit so that we knew what we were looking at. And certainly in that modelling, there was the idea that the black hole was tilted over a long way, and basically tilted over so that we were more or less looking down the poles of the black hole. And that surprised me, in fact, but that was what the modelling suggested. Now, there might be more work done on that. We might learn a bit more about it. But James's question's right on the money. It's exactly the same question that I had when these data were released. So I think there's more to discover there, or at least, if not more to discover, more for we science communicators to discover about what the researchers found. But yeah, the modelling did suggest that it was tilted over.
There you go. All right. Thank you, James. Great question. Thank you to everybody who sent questions in, and keep them coming. You can do that through our website, spacenutspodcast.com or spacenuts.io. And up the top, you can click on the AMA tab and send us text or audio questions, or you can click on the little tab on the right, the button on the right that says send us your audio questions or something to that effect. I'm paraphrasing. But yes, by all means. And while you're there, check out everything else, the Space Nuts shop. If you're into social media, don't forget to join the Space Nuts Facebook page. There's also a user-generated page called the Space Nuts Podcast Group Facebook page, where you can get together as audience members and chat to each other and share your stories and your pictures and whatever else you like. It's a fun group. We do keep it clean, but yeah, you're more than welcome to join us there. And regardless of where or how you listen or view Space Nuts, please leave us a review. Reviews help to expand the audience, and that increases the size of the family, and we all get to know each other more and more. And because we're all like-minded, we always have things to talk about. So yes, definitely leave us reviews on your preferred podcast platform. Okay, I'm going to give my voice a rest for another week, and hopefully this time next week things will be a bit more hunky-dory. But that's where we're going to leave it for another week. Fred, thank you so very much.
Pleasure. Well done, Andrew. You got through it. Your voice actually sounds pretty good now. I think run it in a bit.
Sounds dreadful to me, but I'm sure it'll get better. Just need to rest it.
Yeah, it will.
All right, Fred. Thank you. We'll see you soon. Professor Fred Watson, astronomer at large, joining us every week on Space Nuts. Thanks to Hugh in the studio, who's been pushing all the buttons and flicking all the switches, and he just likes to watch the lights go on and off. That's basically it. But thank you, Hugh. And from me, Andrew Dunkley, thanks for your company on this edition of Space Nuts. We'll catch you on the very next episode. I'm padding because I can't find the outro. There it is. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.
Ah, yes, padding, the old radio trick. When you need to burn a bit of time, you just jibber-jabber away for a few minutes or a few seconds.
Well, you did it very well. It didn't sound like it's good.
Well, if you listen to radio long enough and you hear somebody starting to talk a little bit more deliberately, that's why. Because they've lost something, or they know they've got to do something, but they haven't loaded it, whatever. Yeah. Anyway, goodbye to our live audience. Thanks for tolerating this and that.
Yeah, thanks for tolerating this.
See you next week.